Okay, so this would be days 1 and 2 of Math Analysis summer course. Some data analysis. So I'm just going to go through a few of these problems, and then you'll have an explanation of how each one goes. So the chart below shows how many miles per gallon a car gets while traveling at certain speeds. Use the chart to answer the following questions. So we've got speed, fuel economy, speed, fuel economy. So really this is just a way to write a bunch of speed and a bunch of fuel economy, but we've got it in two separate places. Create a scatter plot of the data and sketch it right. Be sure to label your, probably supposed to say label your axes would be what I would guess. Okay, so we could do that by hand, but we're going to need our calculator later. So I'm going to get out the calculator and enter some of this data. So of course what we can do is go to Stat Edit. I've got some stuff in here, so I'm going to scroll up and clear some of this data. So let's see here, I can do clear enter, scroll over to L2, clear enter, scroll over to L1, clear enter, and now I can enter all my data. You'll have to fast forward, this is probably boring. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Those are my speed values, or my inputs, and my outputs. Fuel economy, 22.3, 25.5, 27.5, 29, 28.8, 30, 29.9, 30.2, 30.4, 28.8. Make sure I'm still matched up. I am. 27.4 and 25.3. Once I have the data in there, I can simply go back to stat. Actually not stat, but rather stat plot, which is second y equals. And I'm going to hit enter on plot 1. I do want a scatter plot, and L1, L2 seems like a good choice. So if I then do zoom 9, which is the statistics, I should get that scatter plot. So if I just give a very basic sketch of that, I would get, one here and here and here, a couple up here and here. So I'm just giving a very basic sketch of this data, but it should look something like that. From there, I can do some other things. It says use your calculator to find an appropriate model for the data. Write the regression equation below and draw it on the graph above. Well, this looks like a quadratic to me. It looks very much like a quadratic. So I'm going to do stat, calculate, and I'm going to do a quadratic regression. And your screen may look different, but you end up with a regression that looks like that. So this is going to give me negative 0.008196 x squared. Let's see here. Plus 0.7458x plus 13.472. So that's the regression equation that I got. And it says, why did you choose the model from part B? Use the grid to sketch a residual plot. Well, I chose that model because it looks a lot like a quadratic model. If I did want to graph this on my calculator, what I could do is I could say, you know what? Go back to y equals. In y sub 1, I can do vars, y vars, actually not vars, y vars, but rather vars statistics, and then go over to equation, regression equation, and there's my regression equation. So now if I graph it, it's going to graph it right on top of my data. Seems to match it pretty well. I'm just going to go deal with something here, and then I'll come back. Sorry about that. So it seems to match it pretty well. Another way I could check is to look at the differences and notice that certainly my first differences are not the same, because here, you know, I'm going +3 and then +2 and then +1 and then I'm down some, and then it just doesn't really seem to match up well like that. I guess it could be trigonometric. We can look at a residual plot and see how well it matches. Remember that to do that, you can go to Stat, Edit, and go over to L3 and then hit Enter. And then we're going to go to List, which is second stat. And we're going to scroll down to Residuals, which should be somewhere. You can hit Resid. And then it's actually going to give me all my residuals. If I want to graph those, what I can do is I can go back to Stat Plot. I'm going to turn this one off so that I'm not getting the original data. And then I'm going to go to Plot 2. And I'm going to turn that on. And I'm going to just simply do L1 versus L3, because L3 is where I put the residual stuff. And then I can simply, I could also just put resid in there. But then I'm going to go back to my graph. I probably want to turn that off. That's not really what I want on right now. That's my regression equation. So I'll go back to y equals, turn this one off. And then if I do zoom 9, it should graph my residuals. So the nice thing about this here is that it's giving me a sense for how good my model is. So remember that I really want that stuff to be random. And it does look pretty random. You know, it's got some stuff here, 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 and here, and here, and here, and here. So my residual plot's looking pretty good. Got that random amount there, random scattering of plots. So I'm not going to put the full explanation here, but we can see it pretty clearly models pretty well. And my residual plot doesn't follow a pattern, and a pattern might indicate that something else works a little better. So using your model, at what speed will the car be running most efficiently? Well, most efficiently means I want my fuel economy to be at a maximum, right? Maximum miles per gallon. So really what I'm looking for is the vertex up here. So coming back to my equation, y equals, I'm going to turn this on and turn my plot off. And then I'm going to do, I'm going to graph this. So it's not going to show up because it's in the wrong window. It might be good to actually turn the other stat plot on so that I can do zoom stat and it'll actually zoom it to the right thing. So zoom 9, I gotta wait, but I can do zoom 9 and there it's going to show up. And now once I have the right window, I can turn my stat plot back off if I want to. And there, then I'll just have the graph. So to find that maximum, which would be the efficiency, I can do second calculate maximum, and then I can just make sure I'm on the left, hit enter, make sure I'm on the right. This calculator's a little slow, and hit enter, and then I can come back and guess somewhere in the middle. And that is going to give me x equals 45.498 and y equals 30.44. So it says how many, using your model, at what speed will the car be running most efficiently? So I'd say approximately 45 miles per hour. How many miles per gallon will the car be getting at that speed? I would say approximately 30 miles per gallon. So that makes good sense. And then finally, we've got this last question which says, using your model, find the fuel efficiency when the car is idling. So if I plug 0, idling, which would be 0 miles per hour, into my regression equation, I actually get 13.472 miles per gallon. What? That doesn't make any sense if you're not moving at all. So then the question says, is this a valid approximation of the fuel efficiency at this speed? No, of course not. Right? That really doesn't make any sense. This thing is modeling the points up here, and it's modeling pretty well for speeds, you know, greater than 15, but for less than 15, it's not going to model them well. So we'd say, no, this really doesn't make sense. You're not getting 13 miles per gallon when you're not moving at all. So that kind of takes care of that problem. Okay, so we'll turn the page here and look at another problem before moving on to the next section. Data set below is presented in ascending order. Set has a mean of 39.83 and a median of 40.5. It says solve for x and y. Okay, so mean, meaning that I need to add up all of these. So 13 plus 27 plus 33 plus x plus y plus 63. I needed to be able to divide by 1, 2, 3, 4, 5, 6 and get 39.83. So that gives me one equation with x and y. To find the median of 40.5, well, the median needs to be in the middle. Now, what I know is because I have an even number of terms here that the median needs to be halfway in between 33 and x. So 33 plus x divided by 2 needs to be 40.5. And that allows me to solve for x. So what I can do now is say, well, then 33 plus x needs to be 2 times 40.5, and 2 times 40.5 is 81. Subtracting 33, I get x equals 51 minus 2, which is 49. Plugging that in over here, I should get y plus, use my calculator to help me out here, and I'm going to say 13 plus 27 plus 33 plus x, which was 49, plus 63 is 185, equals 6 times 39.83, which is 238.98. So y should be that minus 185, which is 53.98. So I found y and I found x using my definition of mean and median. Number 3 says if a city averages 60 centimeters of rain per month during the 5-month rainy season and 9 during the other 7 months of the year, what is the mean amount of rain in this city for the year? So this is a weighted average. I've got 5 months at 60 centimeters. I've got 7 months at 9 centimeters. And I've got 12 months total. So that should be simply 5 times 60, which is 300, plus 7 times 9, which is 63. Probably should have done that in my head, divided by 12. And that is 363 divided by, 363 divided by 12 happens to be 30.25 centimeters. Now that's the mean amount of rain in this city for the month. So if that's for the month, I would need to multiply by 12, and that would give me 363 centimeters per year. Explain the meaning of standard deviation. Well, standard deviation is a measurement of how far points are from the mean. So remember that what you end up doing is you end up saying, you know what, I'm going to take the mean, I'm going to subtract off each one of my x values, or my x by values, my data points. I'm going to square them, sum them up from I equals, say, 1 to n, however many points you have. And then I'm going to take the square root of that business, and then I'm going to divide by n, or n plus 1, depending on whether it's a sample or a population. However, mean minus each point. That's the difference between the mean and each point. You're squaring it. That makes it positive. It also weighs the outliers more. Then you're adding all those distances up, taking the square root to get back to the same units, and dividing by n to average them. So the meaning of standard deviation is that it is a measure of spread. It is a measure of how far your points lie away from the mean. And that takes care of days 1 and 2.